Hello and welcome. In this tutorial, I'm going to go ahead and show you how to implement dynamic stack using C programming language. We are going to use a dynamic array for the implementation of stack using C. Now, in case if you do not know what is a stack, let me give you a brief idea of that first. A stack is a linear data structure with only one open end where we insert an element and we can delete element. And that's the top end of the stack. Let me give you an example from the real world. You can consider the stack of books. Now, if you consider that stack of books, if you want to place a new book into that stack, you're going to place it at the top of the stack, right? And whenever you want to delete a book from the stack, you need to pick it up from the top of the stack as well. And that is why always the elements of stack follows last in first out order. That means the element that you insert into the stack last, that's going to be deleted from the stack first, or vice versa. The element that you insert first into the stack will be deleted last from the stack. Now, the insertion operation for a stack is typically called the push operation. So this push is a behavior of a stack and that receives a value and it's placed by the push operation at the top of the stack. Now, there may be a situation when the stack is entirely full and there is no more provision for another value. In that case, what we are going to do here in this program will double the size of the stack. So whenever the stack is full, we are going to double the size of the stack and then we are going to place the value at the top of the stack. So that's going to be the behavior of a dynamic stack. And then the deletion operation from a stack is typically called the pop operation. So whenever we make a call to the pop operation, it's going to delete the element at the top of the stack if the stack is not empty. And there is one more operation and that's the peep operation. Now, whenever we make a call to the peep operation, it's only going to return us the value at the top. It's not going to delete the value at the top. Okay, like the pop operation. Now, the difference between pop and peep, let it be clear to you. If we make a call to the pop operation, it's going to delete the element from the top of the stack. And if we make a call to this peep operation, it's just going to return the element from the top of the stack without deleting it. But both of them are going to return the element. So when we make a call to the pop operation, after deleting the element, it's obviously going to return the element at the top. But if you make a call to this peep, then it's just going to return the element from the top. In both the cases, they are going to work if the stack is non-empty. Okay, so these are the behaviors for a stack. So we are going to implement the stack using a dynamic array. So we'll have an array there with some initial size. Let's consider that the initial size for the array is 5. So that's the size of the stack and that is 5. So we have all these elements there dynamically allocated. And we need to have an integer marker for holding the index of the last inserted element. So we are going to name it as top. So typically for a stack, we name this integer marker as top marker. And initially, we're just going to place that top marker at -1. That's an invalid index, exactly. Just to indicate that there is no element in the stack. So whenever top is -1, that means it's going to indicate us that the stack is empty. Now, whenever we make a call to the push operation, we need to increment the top by 1. So top goes at 0 and we can place the value here at top. You can see that top is right now 0 and that is the index where we placed the last element in the stack. So if we make a call to the push operation once again, that's going to increment the top by 1. So top goes at 1 and then we can place the value here. And if I make a call once again, it's going to go here at index 2 and we can actually place the value here at index 2. Now, if we make a call to the pop operation, then it's actually going to check whether the stack is empty or not. That we can do easily by checking whether the top is -1 or not. If the top is not -1, then the stack is not empty. In that case, we'll get the value from the top of the stack, that's 30, and then we're going to decrement the top by 1. Let me erase this. Okay, so right now the top is at 2 and we made a call to the pop operation. So we are going to fetch this value and we are going to decrement the top by 1. So top goes there at index 1. Now again, if the pop operation is called, this 20 is going to be deleted. Now if you make a call to the peep operation, it's just going to return 20 if the top is at 1. It's not going to decrement the top by 1. So that is how this is going to work. And one more thing that I need to tell you, and that's about the dynamic behavior of the array. So whenever the stack is full, let's consider that the top is right now here. We have inserted or pushed all these elements into the stack, and then we made a call to the push operation once again. Now, since the top is at last index of this array, there is no more provision for this push operation. We do not have any more allocation there for having this value to be placed at the top, right? So top is right now at size -1. That's the condition for checking the overflow. So the stack is overflow. So in this situation, what we are going to do, we are going to allocate another array dynamically with double the size of this array. So if there are 5 elements right now, this array is going to have 10 elements. So the last index is going to be 9. In this case, the size is going to be 10 this time. And we're going to copy all these elements from the existing array into this newly allocated array. So 15, 20, 30, 40, and 50. Top is still going to be here at index 4. And then we are going to deallocate this existing array, the previous array, using the free function that we can do, right? So now this is the array for the stack with double the size of the previous array. Now we can just go ahead and increment the top by 1 and can place the value there at index 5. So this is going to be the behavior when the stack is overflow. When you make a call to the push operation and we find that the stack is overflow right now, we are going to double the size of the array dynamically. We'll copy the contents from the existing array into this newly allocated array, and then we are going to delete this existing array. Okay, so I hope you have understood this logics clearly now. Let's go ahead and dive into implementing this. Okay, at the beginning, we need to create a structure for the representation of our stack type. So let me do that first. Type def struct. And then within the structure, we need to have a pointer there for holding the base address of the dynamic array. And we consider that our stack is going to hold integer type data. So here within the structure, the first thing I'm doing is that I'm declaring an integer pointer there. I'll name this pointer as data. And as I said, this data pointer is going to hold the base address of the dynamic array, which is going to hold the data for the stack. And then obviously we need a top variable. So integer top is there. Now when we create the object of this stack, we need to allocate that dynamic array for some size. And then we need to initialize that top with -1. And one more thing that we need here in this structure is the number of elements allocated for this array, which is pointed by that data pointer. That's always required. So here is the size. Okay, so this size is going to hold the total number of elements currently allocated dynamically and is pointed by this data pointer. Okay, so I'm going to name this structure as stack. So that's the type stack that we just created. Now let me declare the methods that we are going to implement here for the stack behaviors. The first one is obviously the push method, and that's going to receive the pointer to the stack object. So stack pointer sp. And then it's going to receive a value that we want to push into the stack. So this sp pointer is the pointer to the stack object in which this push operation is going to push this value. Now let me just declare another method, and that's obviously the pop method. Now this pop method is going to receive the pointer to the stack from which we want to delete the top element. So it's going to be stack pointer sp. And then we need another method there, and that's the peep method. So this peep method, as I said earlier, is going to return the top element of the stack if the stack is non-empty, and it's never going to delete the top element like the pop does. So it's going to be peep, and this method is just going to look into the top. So again, this is going to receive the pointer to the stack object from which we want to get the top element. Okay. So these are the 3 methods that we are going to implement now. First, we'll start with this push behavior, then we are going to write that pop, and finally we are going to write that peep method. Okay, so let's start with the push method. The first thing in the push method that we need to do here is to check if the array is overflow or not. If the array is overflow, we need to double the size of the array that I mentioned earlier. So how can we check if the array is overflow or not? So we can just check the top, and if that top is actually at size -1, then obviously the array is overflow. Now you need to use this arrow operator because this sp is the pointer to the stack object. You're going to declare that stack object in some other method, maybe in your main method, and you are going to pass the address of that stack object here in this push method, right? So this sp arrow top is going to be the top of the object for which you passed the pointer here. So if that top is actually right now at last index, which we can actually check in this way, sp arrow size, that's the size of the stack currently. So if that top is equals with size -1, then obviously it's overflow. Then what you need to do here is to double the size of the array, double the size of the array. Now here, how we can double the size? It's really simple. Let me just declare another pointer here, integer pointer temp, and let me go ahead and allocate the array for this temp, which is going to be double the size of the existing size. So we can easily do that using the malloc function. So integer pointer and malloc, then size of integer times sp arrow size. Let's not forget that the size of the stack currently is there in that variable size in the stack object. So times 2. Now that's going to allocate the array with the double size. Now if temp equals null, then we cannot allocate any more space there. We know that. In that case, I'm just going to go ahead and print error message. Now in C, we just cannot throw an exception. If you're doing the program in Java, probably you're going to throw an exception from here. Or if you're doing it in Python, you're going to raise an exception at this point because we are unable to allocate the memory there. Okay, here we are just going to print error message there. Error, unable to allocate memory. And we are going to return from this push operation. Okay, otherwise, if the memory has been allocated successfully, then we will be here at this point. Now here, we need to copy the content of the existing array into this temp array. And for that, we can go ahead and write a for loop. So I'm just going to declare a for loop counter as integer. So we're going to start from I equals 0, then I less than sp arrow size, that's the total number of elements currently there in that stack, or you can use less than equals sp arrow top. That's going to work equally because the top is at last index right now. And plus I, then temp square bracket I is going to get the value of sp arrow data square bracket I. So the content of the ith element in the current dynamic array is copied into this temp array. And when this is done, when we are coming out of the for loop after copying, we are just going to delete that data array. So this is going to be freed here. So I'm making a call to the free function and passing that sp arrow data. That's the base address to the current dynamic array. And then we need to actually assign the address of the new array into this pointer data. So sp arrow data is going to get the value of temp. Now temp is currently holding the address of the newly allocated array, and that we are assigning to the data pointer. That's the actual pointer for our stack array. And after this, we need to update the size variable. So size times equals 2. Okay, so that is it. That's going to double the size of the array by keeping the elements intact. Now, if that is done, the general task has to be written there. And the general task for the push operation is just to increase the top by 1 and then place the value at the top index of the array. And that we can do in this way, sp arrow data within the square bracket plus sp arrow top equals value. That's the push operation. Okay. So let me just reiterate once again what I did there. At the very beginning of the push operation, we are checking if the array is overflow or not. If that is not, we are straight away coming here and incrementing the top first. As you can see that I have used that pre-increment operation. So the top will be incremented by 1 first, and then that top is going to be utilized as index. So at that index where the top is right now, we are placing this value in that array data. Now we are using this arrow because this SP is the pointer to the stack object, and in order to access the member of a structure object using the structure pointer, we need to use this arrow operator, and that I'm doing exactly in these two cases. Okay, so I hope you have understood this. Now when the overflow occurs here, we are going inside of this if block, and I'm allocating another array with double the size of this existing array. Current size is kept here in the size variable, and you can see that I'm doubling the size here by multiplying that size with 2 and passing that total size here into this malloc function, and that's going to allocate the memory, and it's going to return the base address to the newly allocated memory that we are assigning here in this temp variable. Now again, we are checking whether the malloc function is successful or not. If that is not successful, we are just printing the error message and returning to the caller. Otherwise, we are copying the existing data from the data array into the temp array or the newly allocated array, and then we are freeing the data array, and then we are assigning the address of the newly allocated array into the data array and doubling the size again, updating the size variable. So that's it is the push operation. Now let me do the pop operation here. If the top is at -1, then that's underflow. So in this case, when the stack is underflow, there is nothing to delete from the top. The stack is empty, right? So in this case, we can actually return some absurd value, since the pop operation is always supposed to return an integer as we promised here with the return type. So even if the pop is saying that the stack is empty, in that case also your pop operation must return something. That's the constraint here, because if you have a return type there for a function, you cannot go like this. Sometimes you are returning a value, sometimes you are not returning a value. Always your function must return a value. So practically, when the pop operation finds that the stack is empty, it has nothing to return. But still, since we have this return type here, we need to return a value. So we are actually returning some abstract value from here. Say, I'm just going ahead and returning, say, -1001. Now, if this value is returned by this pop operation to the caller understands that there is underflow in the stack, and we assume that this value will never exist in the stack. So this is the absurd value we are returning to the caller as a flag in order to indicate that the stack is empty. Otherwise, if that is not the case, we need to get the value from the top, and we need to return that, and we need to actually decrement the top by 1. So here you can see that I'm accessing the array, and then we are getting the value from the top, and after getting that, we are decrementing the top by 1. So I have used this post decrement operator. So at the beginning, the current value of top will be used in order to get the data from that data array, and then the top will be decremented by 1. So that's how the pop is going to work. Now let me just write the peep method. Now it's going to be just equal with the pop method, except that we don't need this minus to be applied there after that top, because we don't want to update the top there when we just want to look there what is there in the top of the array. So we are not updating the top here, you can see that. So we are not practically deleting the element from the top of the stack. So we are just returning the element from the top of the stack, and if the stack is empty, we are still returning this absurd value there from the peep operation. Okay, now we need to write one more operation there, and that's the init operation, and that's going to return the base address of the stack after allocating the stack, and it's also going to initialize the top and the size accordingly. So it's going to return a stack pointer. So this method we need to call at the beginning when we want to construct a stack. So init, and then it's going to receive the size, the initial size for the stack, and here we are going to construct the stack. So it's going to be stack pointer and then malloc size of stack, and if that malloc fails, so if sp equals null, then we can just go ahead and say that unable to allocate memory, error, and terminating the program. Since we cannot allocate a stack, we don't want to let the program go further. So we are just using the exit method and passing 1 there because this is erroneous termination. Okay, now that allocation is done for the stack object, we can go ahead and initialize the elements there. So SP is the pointer to the stack object that we just created dynamically. Now this object contains 3 things there. One is the integer pointer, data, and that's going to hold the base address of the dynamically allocated memory, which we have not allocated yet. So don't confuse this allocation with the allocation of the array. We have not actually allocated the array yet. Now once we are done with this malloc, we have the stack object created. So SP is pointing to the stack object, and that contains a data pointer, which is right now containing garbage, and the array is not yet allocated. And there is a top that has to be initialized with -1, and there is a size. We need to initialize this size as well. So we have not allocated this array for the stack yet. That we need to do here. So first of all, let's do that. So we need to just go ahead and allocate the array and assign the base address to this data pointer. So it's going to be something like this, integer pointer and then malloc and then size of integer times size. Now if we mention this size, this is this parameter size. Now when we make a call to this init method, this is going to receive the size of the data array. So that's going to be the size of the stack initially. So here we are passing that size times size of integer to the malloc function, and malloc is going to allocate that memory. Now we need to check if that memory is allocated. If not, then we just need to get out of this program. So if data equals null, then we need to just print that error message and exit from this program, because we cannot proceed without the allocation of this array. Now if that is done successfully, then we can go ahead with the program, and first of all we need to initialize the top with -1 and then sp arrow size equals size. Now if the initial size is 5, then we are assigning that here in this object, or the size property of that object. So if you pass 5 here as the size for the initial array, then that is assigned here in this size attribute of that object, stack object, and the top is initialized with -1. And here with this malloc, we are actually allocating 5 element array dynamically, and the base address to this is actually preserved here. Let's consider that 5000 is the base address of this array. So this data is right now pointing to this. So that init method is really important. It's allocating the stack dynamically, and then it's returning the base address to the caller. So this stack object is allocated dynamically, and this array, integer array, that is also allocated dynamically. You must realize this. Okay, now let's go ahead and return that pointer to the caller. So here we go, return sp. Now let me go ahead and make a declaration of this method. I actually implemented that method init without the declaration. That's not a good practice. So here's the declaration, and then I implement that method here. Okay, so we are done writing all these methods. Now let's go ahead and see if we can create a stack practically or not. So here we go, stack pointer s1 equals init, and we need to pass the size there. Now that's going to construct a 5 element stack. Okay, now let's go ahead and push some values there into this stack. So I'm just making a call to the push function. We need to pass the base address of the stack into this push function and the value. So push will actually push that 10, and then let me just make a call to the push function once again, one more time, and 40. Okay, I'm pushing 50 now, and that will make that stack overflow. That stack is right now full with all those 5 elements. Now if we want to push one more element, it's actually going to double the size of the array. So if I just print the size here, so size of the stack %d \n and then s1 arrow size, and then I'm just trying to push one more element here, and that's 60, and let me print the size here once again, then it's going to be 10 actually. So let's go ahead and run this program. So I'll hit on this terminal, and by the way, I'm using Visual Studio Code for developing this program. You can use any IDE of your choice. You can use Code Blocks or Visual Studio or whatever you like. So I'm just going to the terminal and let me just compile this. GCC stack.c, it gets compiled. So you can see that size of the stack was 5, and after that insertion or pushing of 60, it's actually doubled to 10. Now let's go ahead and check the values by popping them. So I'll just, let me just close this terminal. Okay, so here I'll just do the pop. So while S1 arrow top not equals -1, let me go ahead and pop the values from the stack and print them into the console. So %d \n, and then I'm making a call to the pop operation passing the address of the stack object. So now if I go ahead and run this program once again, gcc space stack.c compiled, a.exe will be created. If you are using Unix or Mac or Linux, then it's going to be a.out, and I hope you know how to execute that. It should be /a.out. So here we go with the execution. Just typing A and hitting the return key. You can see that it's just coming out in the reverse order. 60 was inserted last and we get that first, and then 50, then 40, 30, 21, and after that top goes at -1 and the while loop gets terminated. So that's how we can actually implement a stack dynamically in using the C programming language. So I hope you have understood this clearly now. Okay, let's now go ahead and build a menu system there in the main method in order to make calls to these stack operations, and that's going to make this program more interactive. So in the main method, let me just comment out all these things out there. Now here, first of all, I'm going to ask the user to input the size of the stack, and that's going to be the initial size. So here you can see that I'm printing this to the user, and then I'm reading the size here using that scanf, and I'm going to use that size here in order to allocate that stack. So I'm passing that size to the init method, and now let me go ahead and write a loop there, and this loop is going to continue as long as the user wants them to continue. So I'm going to have a flag there, or let me just name this flag as quit. Initially it's going to be 0. When user wants to quit, we'll turn this to 1. So as long as not quit, we need to iterate in this loop, and I'm going to go ahead and print a menu system there. So for option 1, we are providing the service for the push operation. For option 2, it's going to be the pop operation. For option 3, it's going to be the peep operation. For option 4, let me just print the size of the stack. So size of the stack. Now we are going to ask the user for their choice. So enter your choice, and then we are going to scan that. Okay, so let me declare a variable choice here, integer choice, and here we are going to read that choice. So with this scanf, I'm reading that choice. Now we need to have a switch case statement there, and there inside of the switch case we are going to make the calls to the appropriate method as per the user's choice. So here we go with the switch case. Switch, we need to switch this variable choice, and case 1, that's going to be for the push operation. So when the user chosen this option 1, we need to ask the user to input the value for the push operation, enter value to push, and that we need to read here. So let me just declare one more variable there for holding this value. So I'm just going to declare it as with the name value there. Now let me read that value here using that scanf. So that's going to be %d and then ampersand value. Now we need to make a call to that push method. The first parameter, we know that it's the address of the stack object, and the second parameter is obviously this value that we want to push. So there should be a break. Now let me just print a message there. So with that, we are done with case 1. Now let's go with the case 2. Now here we need to make a call to the pop method. So I'm just going to make a call to the pop method here, value equals pop, and as parameter we need to pass the address of the stack object, and that is S1. Now if the value is -1001, we know that it's actually indicating that the stack is underflow. So we are just going ahead and printing that stack is underflow. Now you can actually go ahead and make it more appropriate by testing the top as well. So if top, I mean S1 arrow top equals -1, and we get that -1001 as the return value from that pop operation, then it's indeed underflow. Otherwise, it may be that -1001 is a value there, is a legal value there in the stack that we pushed earlier. So else, we need to go ahead and print the value that is popped. So popped data %d \n and then that value. Now the pop operation is done. Now we can go ahead and write that case 3 there for the peep operation, and that is going to be exactly same as the case 2, but instead of this pop this time we need to make a call to the peep operation. And if the peep returns -1001, then the stack is underflow. Otherwise, we can say that the peeped data, or the data at the top is then printing the value here. Okay, so now let me just have that case 4. It's the size of the stack. Now one more thing that we need there, and that's the exit option. If the user wants to exit, we need to provide that choice as well in this menu. So option 5 is exit. Now option 4 is just to print the size of the stack. So here in option 4, if user chosen that option 4, we are just going to go ahead and print the size of the stack. So size of the stack is %d and then \n. Let me print S1 arrow size. Okay, now let me give a break. Now case 5, in this case, we just need to turn that quit flag to 1. We need to assign 1 to the quit flag. So on the next iteration, this while loop is going to be, this condition in the while loop will be false. Okay, so when quit is 1, not 1 is 0, we are going to come out of that while loop in that case. Now this is the end of the switch. So end of switch. And this is the end of the while loop. Okay, let me have one more option there. That's the default. If user has given something other than this 1, 2, 3, 4, and 5, then this default case will be executed, and there we can just go ahead and print a message to the user that they have actually given invalid option. So invalid option, valid options are 1, 2, 5. Okay, with that we are done. Let me go ahead and run this program. And as I said, this time it's going to be really interactive. So let me just compile this. Now I have actually saved this program under this folder stack, which is under this DS2019, which is under this Shivaji and under that. And that Shivaji folder is obviously under that C drive. So if you want to compile from the command prompt, you need to go inside of the folder where you have saved your file. So here we need to apply the gcc command and then the stack.c, and here it is, it's done. And that creates, that compilation process creates the exe file. You can see that this is the exe file that has been created by the compiler. So let me go ahead and run this program. So first of all, it's asking for the size. Let me give 5 as the initial size. So the stack has been created. Now if I just go ahead and provide option 4, you can see that size of stack is 5. Now let me push some value there, 10. So that has been pushed. Let me push 90. So that pushed again. 20. I'm sorry, 20 is not in an option. So it's invalid option. So let me give 1 again, and then 20. That's pushed there. 1 again. 80. 1 again. 40. Now let me check the size there. It is still 5, but if I just go on and push one more element and let me check the size, is 10 there. So size has been doubled. So that's how we wrote that code. Now if I just go ahead and use the pop option, that's option 2, then we get 100 there. That's the last one. Then 40, then 80, 20, 90, 10, and stack is underflow. So this time it's much more interactive. So let me just go ahead and provide that option 5 to terminate this program. Okay, with that we come to the end of this long session. I hope you have understood the implementation of dynamic stack using the C programming with this tutorial. If you liked this video, then please hit on the like button. You can subscribe to my channel by hitting the subscribe button and hit the bell icon so that you are notified immediately whenever I upload a video. Now I'm going to upload some more videos on data structures and algorithm in near future. You can share this video with your friends, and for that I'll be really grateful to you. Thank you for watching this.